two bodies A and B of mass 2 kg and 6 kg is in contact with each other, rest on a table against a rigid wall. The coefficient of friction between the bodies and the table is 0.2 and a force of 200 Newton is applied horizontally to A. Find the net force on the partition. So here the net force on the partition means the force that wall exerts on the masses. So let it represented by N, and there is a frictional force which is a static friction because of the application of this 200 Newton force. So since there is no acceleration, N must be equal to 200 minus the frictional force, which is 200 minus mu times 6 plus 2 is into 10. So this is 200 minus 0.2 into 8 into 10. That means 200 minus 16 is 184 Newton. This is the force that the wall exerts on the bodies. Option C. Now the seventh problem says the rear side of a truck is open and a box of 350 kg mass is placed 4.5 meter away from the open end as given in the diagram. The coefficient of friction between the box and the surface below is 0.2. On the straight road, the truck starts from rest and accelerates with 3 meter per second square. At what distance from the starting point does the box fall off the truck? So assume that you are sitting on the truck and in your frame of reference, the forces acting on the box are the following. There is a fictitious force MA and there is a frictional force F. So the net acceleration in your coordinate system is MA minus mu mg divided by m, which is A minus mu g, and A is 3, mu is 0.2 into 10, that means 1 meter per second square. So the box will be accelerating in this direction with acceleration 1 meter per second square in your reference frame. So now we need to find out how much time elapses before it falls from the truck. So to fall from the truck, it has to travel 4.5 meter, and that is equal to half into 1 into t square using this formula, and u is 0. That implies t is square root 9, which is 3 seconds. So in 3 seconds the box will fall from the truck, and in that 3 seconds how much distance the trucks travel, we have to calculate that. So again we will use half into the acceleration of the truck is 3 into 3 square, that is 27 by 2, which is 13.5 meters. Option A. Now the question is, in an experiment on the specific heat of a metal, 0.3 kg block of metal at 120 degrees centigrade is dropped in a copper calorimeter which has a water equivalent 0.025 kg. That means its mass is same as of water of 0.025 kg containing 100 cubic centimeter of water at 27 degrees centigrade. The final temperature is 35 degrees centigrade. Calculate the specific heat of the metal. So you see the options are given in joule per gram per Kelvin. So we have to use gram instead of kg. Now the heat that the metal releases when cooling from 120 degree centigrade to 35 degree centigrade is mass, which is 300 grams, into the specific heat S into 120 minus 35 that must be same as the heat taken by the calorimeter with water. So the mass of the calorimeter is 0.025 kg plus the mass of the water of 100 cc is basically 100 grams. Sorry, this is 25 grams. 0.025 kg is 25 grams into 4.18, which is the specific heat of water, 4.18 joule per gram Kelvin. So into 35 minus 27, and you need to calculate this S, and if you calculate you will get S is equal to 0.215 joule per gram per Kelvin. So none of the answers is matching, and the official answer is given option B. If you know how to arrive at that, then you can comment. Question number 9 says, given an isolated conducting spherical cell radius 30 cm, some positive charges is given to it so that resulting electric field has a maximum intensity 1.8 into 10 to the power 6 Newton per coulomb. The same amount of negative charge is given to another isolated conducting spherical cell of radius 60 cm. First cell is placed inside the second, so that both are concentric, that's given in the figure below. Find the electrostatic energy stored in the system. So since if the inner spherical cell contains a charge q, the outer spherical cell contains charge minus q, so the electric field outside the outer cell is zero because of Gauss law, because there is no net charge enclosed in this Gaussian surface. And the second thing is that, as we know, for a sphere the maximum electric field occurs at the boundary at the radius, and then the electric field falls off. So E at a distance r, which is greater than the radius, is basically E max divided by r square. And we know the electrostatic energy stored per unit volume is half epsilon E square. So electrostatic energy that is stored in this volume is U is equal to half epsilon 0 E square into 4 pi r square dr from 30 centimeter to 60 centimeter, and that is basically half epsilon naught 4 pi E max square into 1 by r square dr into r square, and 1 by r to the 4 into dr into r square, because there is E square. Now you need to perform this integral from 30 centimeter to 60 centimeter, and you will get the answer 0.03 joule. Option B is correct. Question 10 says, about 10% of the power of 100 watt light bulb is converted to visible radiation. What is the average intensity of visible radiation at a distance 2 meter from the bulb, at a distance 5 meter from the bulb? So the visible radiation is coming out with a power W visible is 10 watt, because it is 10% of 100 watts. Now intensity is defined as power divided by unit area. Now assuming that the light actually the intensity coming out of the light is isotropic in nature, so if you need to find out what is the intensity at a distance r, then you need to divide it by the area of the sphere that has a radius r. So in this case this is 10 watt divided by 4 pi and 2 meter square, and if you calculate this, that you are going to get 0.23. so only one option is 0.23 for A, so option A is correct. Now which of the following is correct expression for maximum possible speed of a car on a banked road? So let's draw the free body diagram. Suppose this is the banked road and the car is like this. Banking is theta. There is this mg. This is the frictional force. This is the normal force, which makes an angle theta here, and this is also theta, and you have a centrifugal force which is mv square by r, and if you draw this, then this angle is 90 minus theta and this angle is theta, so this is again theta, and our xy direction is like this. So for maximum velocity, you can see along y direction, this is n should be equal to mg cosine theta, this component plus mv square r, mv square by r sine theta, which is this component of this force, and frictional force plus mg sine theta must be equal to mv square by r cosine theta. So f is mu times n, so this is mu mg cos theta plus mv square by r sine theta plus mg sine theta is mv square by r cos theta. You cancel out m's and divide by cos theta and evaluate v. So v would be, actually it would be r into square root of g mu s plus tan theta divided by 1 minus mu s tan theta. So option D is correct, except the fact that r is under square root, but actually it will come out as out of the square root. Okay. 12th problem. A 60 kg man stand in contact against the inner wall of a hollow cylinder drum of radius 4 meter rotating about its vertical axis with 180 revolution per minute. The coefficient of friction between the wall and its clothing is 0.2. Find the minimum rotational speed of the cylinder to enable the man to remain stuck in the wall without falling when the floor is suddenly removed. So basically, here is your man. This is the mg force and this is the frictional force acting on the person, and this is the normal force, and this is the m omega square r centrifugal force. So the person will stuck to the wall when F is equal to mg, that means mu m is equal to mg, that means mu m omega square is mg. So omega square is g by mu into r, and you will get, if you evaluate omega, you will get 12.5, but the official answer says it is 18.5. Now question 13 says an uniform magnetic field of 2 Tesla exists in a cylindrical region of radius 10 centimeter. Its direction parallel to the axis along east to west. A wire carrying current 6 ampere in the north to south direction passes through the region. What is the magnitude of the force of the wire if the wire intersects the axis and the wire in the NH direction is lowered from the axis by a distance of 6 centimeters? So you have two cases. In one case, this is the cylinder and the wire passes like this, passing through the center, the axis of the cylinder. And in the second case, you have a cylinder and this is the axis and it is passing 6 centimeter from the axis. So in the first case, the force is defined as I times the length of the wire, that is in the magnetic field, times the magnetic field. So as you can see, this length is 20 centimeter because the radius is 10 centimeter. So in the first case, the force would be 6 times 20 into 10 to the minus 2 into 2, that is 2.4 Newton. And in the second case, we need to calculate this length. So as you know, this is 10 centimeter and this is 6 centimeter. So this is 10 square minus 6 square root of this, which is 8 centimeter. So this length will be 16 centimeter. So in that case, the force will be I, and this is 6 and this is 16 into 10 to the minus 2 into 2, that would be 1.54, sorry, 1.92 Newton, this one. So the next question is, in a chamber of a uniform magnetic field 4.5 Gauss is maintained, an electron is shot into the field with a speed 4.8 into 10 to the power 6 meter per second normal to the field. Find the radius of the circular orbit and obtain also the frequency of revolution. So as we know, the force on the electron is QVB must be equal to mv square by r. So the radius is mv by qb and m is 9.1 into 10 to the minus 31. V is 4.8 10 to the power 6 divided by 1.6 10 to the power minus 19, and this is 4.5 into 10 to the power minus 4, and if you calculate, you are going to get 6 centimeter. Option C, and you don't even need to calculate the frequency of oscillation. Now 15th problem. Two capillaries whose diameters are respectively 9 mm and 8 mm stand one by one in water, and if the water rises to height 4.5 mm in the first capillary, this is 4.5 mm for example, and for the second capillary, how much distance it will rise? Let's say this is h. So as we know that the force due to the surface tension must balance the weight of the water that has been raised. So that is pi r square into h into rho. So you will have h is 2t by rho r. So as you can see, h is proportional to 1 by r. So h1 by h2 is r2 by r1. h2 is r1 h1 by r2. So this is, since you can multiply 2 here, that would give you the diameter. So this is 9 into 4.5 divided by 8. and if you calculate, this would be 5.06 millimeters. That means 5.06 into 10 to the minus 3 meters. Thank you.